want to thank everybody for joining. We're going to be covering infrastructure monitoring, a little different than what a lot of our customers' primary use cases are, which is more gauging network experience at remote offices and stuff like that. So it's a little bit of a different take. A lot of our customers are starting to branch out into leveraging NetBeez this way, especially with all the different ways that NetBeez can be deployed. And for those of you, which I think a bulk of you I actually meet with pretty regularly, but my name is Stephen Kruger, and I'm a customer success engineer over here at NetBeez. So good to see everybody on the 1st of February here. And how NetBeez can help in this regard. So as a lot of you are already aware, just the stock configuration is going to notify you of an issue within about 25 to 30 seconds. The ping tests are designed with the stock configuration, which you can change to run every 5 seconds, and the up-down default is 5 failures in a row will trigger an up-down detection depending on what test you're running, or performance as well if you have it configured that way. So that's really crucial because you don't want to be notified 30 minutes, an hour, even 10 minutes later that you have part of your transit link, part of your infrastructure, you're not able to reach out to the cloud or the data center. You don't want to be notified, 10, 15, 20 minutes because you already have about 30 support tickets by then. You can use NetBeez to verify where these issues are, if they're widespread or if they're very isolated to one part of the network or one location within a network. SLAs, this is another big thing we're starting to see more and more customers leverage NetBeez, where they have very specific networking SLAs. Usually it's going to be performance and reachability internally or on a particular product that they're running on their network, whether they're hosting something, whether it's a web page that they host internally within their data center, or if it's a solution they're making or whatever have you. Or actually another one I see is that their Wi-Fi vendors or their ISPs are guaranteeing certain SLAs, and they're doing throughput testing from site to data center. They're not getting that. So that would be another example. There's a whole slew of some on-demand testing troubleshooting you can do as well. And then when you have NetBeez spread out across your transit links or throughout different switches and nodes throughout the whole infrastructure, whether it's your core, whether it's around the ring, you essentially have remote access to all different parts of the network. Our focus, though, is not going to be on kind of some of the things we talked about in the last couple events. We talked about the cloud services, the video streaming, the Zoom, the different web applications, even the remote users. That's not really what this part's about. While those are still relevant and have a connection to what we're talking about here, the main point is going to be more of the infrastructure itself, right? The intra-network, if you will, for layman's terms, whether it's on-prem at remote offices, depending on how you have things configured, if it's data centers, or in this case, we have the cloud, right? And that's essentially an extension of most infrastructures that we see nowadays. When it comes to the application, you can use wired sensors. I would not recommend Wi-Fi for that kind of application. I would say most of our customers are probably moved to some sort of virtual application if this kind of monitoring is very important. So if they were brought on NetBeez specifically for infrastructure or cloud or infrastructure monitoring in general, they're going to generally purchase more of a virtual application, whether it's a container or install within a VM. The wired sensors will work fine. They capture it from more of an end user experience perspective, which is why a lot of people like them. But they're not really necessary because there's added cost to actually purchase sensors with the way NetBeez how we do these processes now. So whether you install it within a virtual instance, which is what I do, or install it on a Calus 93 or 9500, there's a bunch of extreme switches, which if you search extreme within our documentation, you'll get a list of which one's supported. A KVM instance, if you actually have an interesting one I saw is they have a bunch of these really lightweight, thin clients that run a Linux OS, and you can, they run the whole building kind of runs through that when it comes to internet and everything. So you're able to install NetBeez there, or Docker container, or a container within the cloud. So those are most of the application. We're not really going to talk about Windows or Mac in this regard. So the first thing I'm going to actually physically show you is when it comes to alerting profiles and setting up to meet your SLAs, because there's a couple different ways we can do this. I have a bunch of different things up. So I'm going to go to settings and then anomaly detection. So the stock configuration of NetBeez as of like version 7, I think, is going to have these 5 consecutive failed tests. And then they'll have like a 4x baseline placeholder kind of test for you. What I have configured here, and there's 2 really important ones we're going to talk about, is 2 consecutive failures and 10 milliseconds over 1 minute performance testing. So there's a whole slew of different kind of alerts you can set up. You know, the up down is pretty normal. Down up, if you have parts of your network that should not be able to communicate, there'd be some value there. Baseline, when we're talking about infrastructure monitoring, we're basically going to be talking about mostly ping and probably trace route, but ping's usually more talked about in this regard. Hops, definitely, you know, how many hops, and if there's an average that you look at. I don't see that as much, but failed trace routes definitely could be applicable. But I would say RTT is more than half the infrastructure monitoring I see here. But what the baseline does is if you have a wide array of different levels of equipment, you have some stuff that's end of life, some stuff that's fresh or just been refreshed, for example, you may not be able to set a very specific baseline with RTT values because the equipment's going to vary, right? You just want to make sure that your network is not having any big changes, you know, minute over minute, 5 minute over 5 minute. For baseline, it's really up to you. 1 minute's a little tight. I run 1 minute for, you know, this example and testing purposes, but the downside of 1 minute is you're only dealing with essentially 12 pings, and if one of them's like way off the chart and it's a hiccup that's not concerning, that can trigger the alert. And while it's not really a false positive per se, it can definitely look that way, or, you know, it definitely very well could be more of a false positive. So 5 and 15 is more the sweet spot when it comes to performance. And for averages, I would recommend 1 week or 1 month. A good example is, let's say you do have a network issue that you solve, but now your 1 day average is skewed for the next, you know, day or so, right? So you won't know for a couple of days if your network's actually back in check or not, because those averages can skew much higher. So 1 week or 1 month, that's going to depend. Some people don't have 1 month retention periods because they have a lot of data that they need in shorter intervals. But 1 week or 1 month is usually good numbers to work with. And you could do like 1.5 times. So, you know, making sure that there's not a great variance, you know, from performance over every 5 minute average. And then watermark is going to be relevant where you're going to set that threshold. Like that's what I'm going to work with here, where, you know, no more than 10, 20, 30, 50 millisecond response time. And maybe 1 minute is what you need, or maybe you'll do over 5 minutes. You know, with 1 minute, obviously it can be skewed easier, but you might want to know that information. 5 minutes, you know, less chance of having some skews in the data if it's not going to be, you know, that relevant. If one ping goes through the roof, it's one failure to one node, may need to be looked at, may not be. So this part's important because we're going to actually come back to this when we look at mesh testing. Any questions before we kind of move forward about that? Okay, cool. So there's 3 ways or 3 items that I monitor in my setup, and it really depends on your infrastructure and what you have. Will depend on what you configure. So when it comes to infrastructure, I mentioned ping, trace route, and also path analysis. Path analysis, I think, is really important, especially if you're going across transit links, going off long distance. If you're going to hit multiple nodes, especially if some of those nodes are not owned by you, you know, that's going to be very important as well. But what's really cool is if you do get any kind of alert, you can get that last hour and you can be very reactive on what's going on. So what I did is if I go to my core, I have 3 tests configured, 1 for each switch in my infrastructure, and I could see, oh, I had a performance blip here. It actually got worse throughout the day. But what's cool is if you click on it and then you click on this right here, as you see, I have cursor over here, it'll populate all the agents that are falling within that bracket. So in this case, it's failing, But if there's a bunch of agents that fell, or actually one agent that fell in the 20 to 40 millisecond, so you can pinpoint very quickly which agent had triggered this in the past. Because once the alert clears, especially because I do 1 minute averages, you can look through all the alerts, but if you had a couple different pop-ups, you might want to figure out, what happened when for a specific test. So this is actually to the database that I run here in my office. And then the last thing before we actually go into like live, what I'm actually doing is Iperf testing. So this is running from my file server to one of the virtual agents I have configured. I have the test set up to be 500 megabits per second faster. If it's below that, you'll get these little anomalies here. 500 is a pretty good number. I typically can run a gig in my infrastructure, but I just have so many devices hitting it that about half that bandwidth is usually ideal. But that's really good because you can configure, if you configure an Iperf server, for example, you can have your entire infrastructure hit it. You can set up staggered test if you want to do that. You can just do all the agents. You can set up different ones if you want to stagger them, if you want to flood your network with traffic. But say you have, 10 core agents that you want to test against the data center. You could set up 10 of them, stagger them, and then you'll be able to get running results, making sure you're getting that throughput to the data center because you're promised so much bandwidth, right? And also with things like path analysis, you can see where the hiccups could potentially be along the way. So let's go over to let's go to targets. So the first one that I have configured here, this is all my core switches. And everything's running pretty good so far. I've had a couple hiccups I showed you guys earlier. So this test instance was the only one over 4, and it was the Pittsburgh Wi-Fi agent. That was running over the Wi-Fi, so you can imagine the response time is going to be higher. It's kind of why I mentioned like the wire devices or the virtual application, because Wi-Fi is going to have a much greater result with interference and everything like that versus a wired device or a virtual device. But I have this hitting all my switches. I think I have it configured every 5 seconds by default. I don't think I changed these. Yeah, these are running every 5 seconds just to make sure all my switches are healthy, make sure all my switches are online. The next test I have configured is my database. I want to make sure, I didn't want to edit that. I want to make sure that all the agents I have configured are able to successfully hit my database. And again, as I mentioned, we have some issues with, that was Pittsburgh HQ, not just the Wi-Fi. So we actually had a really weird hiccup here. And let's actually take a look at that. So as I mentioned, with 1 minute averages, one really high ping anomaly can set off the average, which is why it's important to understand how well your network's going to perform. It's not bad to do some test cases for a day or two before you really hard dial in what your parameters are going to be. But this is another real world example that I'm using. And the last one, we've been asked about this a lot, and that's mesh testing. And it is something that can be configured. It really depends on how far reaching you're going. If you have hundreds and hundreds of agents, it's a little tricky to do it. You can do it. It'll just take some time because essentially what I did was I configured all of the IPs of all my agents and they're running against each other. And at least with the virtual application, what's really cool is if I go to say agents and Albuquerque support's a good example. So you can see Albuquerque's not listed here. So I was able to do one resource with all the IPs of all the agents. And with the virtual agents, they were able to automatically admit the same target, so it wasn't running a test against itself. But what that looks like in this regard is we have all of our mesh testing right here. So you can see pretty much kind of going down. Of course, I don't have the file server mesh test set up. And you can see all the white space pretty much going down at angles, so they don't run against itself. But that is to verify that all of the agents can talk to each other. All points of the network can talk to each other. And I have it configured where if any of these run over 10 milliseconds from node to node or NetBeez agent, it triggers a performance alert, which will show up in the reports. It'll show up in your alerting, depending on what you have configured. And you're able to monitor the entire infrastructure, all the transit links, all the switches if you want. Just really kind of depends on what you're looking for. Now, what I did here, which is a little bit different because for my network, I don't want this to run every 5 seconds. I took an idea from one of our customers that runs a data center, and they run, they're basically a service provider, ISP. And what they configured, and I like this idea, was I did 15-second intervals, but then if I have 2 consecutive failures, it triggers a down alert. I like the idea because it's a little bit less stress on my network. This is a consumer network. I don't have any like really high-end enterprise equipment in this instance. But also I have other people that are on this network. So, but that's what I have configured here, and all the agents are talking to each other, and I'm getting, up-to-date information very quickly to make sure everything's up and running and meeting SLAs, meeting targets, all that stuff. And then the very last thing, I promise, and we're actually right on time than I expected here, is Iperf testing. So this is also the real world test. I showed you this in the screenshot earlier. This is running from my file server to the Pittsburgh agent. The reason why it's important is I do move data across the network to my file server, not as much as I used to, but like even when I edit YouTube videos, my file server is encrypted and everything. So that's where I store all the temporary data. And I want to be able to make sure that I'm getting a decent amount of throughput, because I can be moving a couple gigabytes of data over the network. And what's really cool is while you can run ad hoc, what I can also do, and I don't want to actually do this right now because I'm on Zoom and it's going to actually push maximum bandwidth. But if I click run now, I'll do it anyway. It'll actually run the test now and log it here and into reports. Whereas the ad hoc test is just going to run the report in real time, or run a test in real time, and just show you the results in front of you. But it doesn't store that for things like reporting and against the agent and everything. Because what you can do is you can also go to file server, schedule test results, and then you can see the last 24 hours, the last week, the last 2 weeks. You can see all the tests that I run. I shut the server, or I shut the agents off on the weekends when I'm not working. So, but yeah, you can see all the tests that are running week over week and everything day over day. But yeah, so that would be pretty much the last way to measure infrastructure performance. If you spin up an Iperf server, would be very useful as well. Or if you have key nodes that need to run against the data center, whatever have you, you can just run, you can set up basically one agent is like the endpoint for the Iperf, and all the other agents configure, stagger them, whatever you want to do directly to that agent. So that is pretty much the bulk of it. I do really appreciate the customers that gave us some insight on this, on kind of how they're doing it. We're getting more and more people who are utilizing NetBeez to monitor the network when it comes to reachability and performance, because all those features are already baked into NetBeez. And it's basically, if you already have NetBeez deployed, it's already something you can configure. So with that, I will take some questions if anybody has any.
Hey, Stephen, I just had a question about the way you have that Iperf set up.
Yes.
So in your environment, what is the sending and receiving side of the endpoints there?
Yeah, so the sending side is actually a Docker container running on my file server, and it's running over my internal network to I have a bunch of virtual machines set up, and it's hitting the agent that's loaded into that VM.
Okay, so one side of the Iperf conversation doesn't even necessarily have to be either the Hive server or even a NetBeez in and of itself, just as long as it's running like I guess probably along the same version of Iperf that the NetBeez themselves are running, then they can just talk back and forth.
Yeah, so yeah, you can, you don't need to do anything special. By default, the Iperf is set up to go agent to agent. The other options, you can do multiple agents to a server you have configured. Just really depends on however you want to configure that. Does that answer your question?
Yeah, I think so. I'm going to try to find the same screen in my deployment just so I can play around with it a little bit, because this is similar to a project that I was recently working on.
Yeah, definitely. Yeah, really good for one suggestion I would make, and I have to remind people that the nature of Iperf is flooding it with actual traffic to measure throughput. So if the tests are going to hit the same parts of the network, I would typically recommend staggering them if you can. because if you run multiple at the same time, they're all hitting the same endpoint. And they're all running through the same series of switches and everything, you could potentially get obviously less performance. You can also measure or put a cap on the bandwidth as well. So a little different than network speed. Network speed is not actually flooding the network with real traffic.
Okay, thanks. I appreciate the explanation there.
No problem. Any other questions? Give you guys another minute to think, and then we'll finish up with one last thing.